So we talk about graphs of quadratic functions. And if that doesn't grab your attention, I don't know what does. Yeah, look at the crowd go wild here. So what is a quadratic function? Well, it's anything in which we probably should put the marker on. X to the second power is involved. So we've had our linear functions, our y equals mx plus b's. We have had our exponential functions when the exponent is a variable. Quadratics are when it's to the second power. So by the end of this, you'll be able to graph, that is, a quadratic function using a graphing calculator, and be able to determine the vertex, the turning point, the zero values, and a few other things. But let's understand vertex and turning point are actually the same thing. So different word for the same thing, and I'll kind of explain why in a little bit. So a couple of things that you're going to want to know that I've already included in your notes, and that is how to find the zero values. Now, we found the zero values last class by factoring a trinomial, or a binomial for that matter, but factoring, setting it equal to 0, and then solving a little equation. Well, doing this process is going to be the same as finding the answers for when they cross the x-axis. And these are also called zero values. So that's going to be something we'll try to relate today. We'll talk about domain and range again. Remember that domain is all of the x values. Because these are U-shaped graphs called parabolas, they go in both directions forever and ever. So we're just going to end up using this for the domain every time, even when it's turned downward. And then for the range, we're going to try to evaluate where the lowest or the highest point is. So when it's the lowest point, everything is going to be above that, so greater than. And when it's the highest point, everything is going to be below that, so then less than. Okay? So it's going to be the turning point and then heading on in either the positive infinity or negative infinity directions. When we come back and look at this later after we do a couple, all that will start to make more sense. But for right now, just a good setup for what we're going to do. Chat looks quiet, so let's get started. We want to sketch a graph of y equals x squared minus 2x minus 8. The biggest reason why this is new is because we have x to the second power, and we haven't graphed anything like that so far. So let's pull up the calculator and go to y equals, where we're going to enter the equation that we have, which is x to the second power. So hit the variable key, square it, and subtract 2, followed by x, and then minus 8. So we've got a trinomial in our calculator. And why don't we go ahead and look at the table? Second and graph. Now, that table shows us some numbers, and we're trying to find the U shape, okay? Kind of like what we saw from the beginning when those parabolas were being drawn. So if I go up just one more, you can kind of see how we have a 0 and a 0, a -5 and a -5, a -8 and a -8, and then just a -9. So because we got some repeated y values, that creates the U shape. So let's go to the notes, and we want to write these down as -2, 0, -1, and again, I'm pulling these right from the calculator, -5, that's a really ugly 5. All right, let's give it a little bit more of height here. 0, -8, and then 1, -9. And then right here, we have found the turning point, because after that, the y values just repeat. So after the -9, it's actually -8, -5, and 0 all again. So -8, whoa, that's going to need to get erased. -5 and 0. So these numbers just ended up repeating, making that U shape that we see on the graph. Now, these continue to go in increasing value, 2, 3, and 4. So now you got enough points to plot this and kind of get an idea for what it looks like. It is -2, 0. It is 1 to the left down 5. 1, 2, 3, 4, 5. It is 0 left to right down 8. Then it's 1 positive down 9. And again, that's where things kind of start to take a turn. I didn't count right at all. That is terrible. Holy moly. 5. Then 8. 6, 7, 8. Whew. 9. Okay. I'll let you correct that because I was way off. Match 'em. So it's going to be 2 and then 8, 3 and -5, and all the way back to 4 and 0. So we have the shape we were looking for. And it's not a V, it is a U. So freehand this, comes down, makes the turning point, turns and goes in the other direction, and then maybe just put some arrows on it to show that it goes in both directions forever and ever. We'll talk about the axis of symmetry. An axis of symmetry is something that cuts something in half, and if you were to kind of fold it on top of each other, you'd get the exact same image. So your face actually has symmetry. So if you were to take a line and draw it from your forehead down the bridge of your nose, through your mouth, you would actually be able to kind of see that on both sides, it's symmetrical, and that's why it kind of looks a little bit more natural, and maybe not so odd, I don't know, alien-like. So our axis of symmetry of this will be the line that goes right through the parabola, right through the center. Now this may have been a long time ago, but this is a vertical line, and remember that vertical lines start with x equals, and then they use the x value. Well, this x value right here is 1 to the right, so positive 1, and x equaling 1. So we found the line of symmetry, axis of symmetry it's called. Next up is the turning point. I'm going to try to color code my notes today so it makes more sense. We've already kind of identified it in the table, but it looks like this in the graph. So it's that very bottom point where everything took a turn. So in terms of a point, it is 1, 9. Now, zeros, roots, and x-intercepts. I'm talking about the same thing when I say that. So these points can be found here and here when the output, when the y value is 0. Excuse me. So when we see that in the chart is when the output is 0 here and here. Now, we do see a 0 for x, but that's something else. That's actually the y-intercept. That was where it crosses the y-axis. So that was still in the equation like it's always been for our linear equations and our exponential equations. But for this, we're talking about an output of 0. So the x values were 2 to the left, -2, and 4 to the right, so -2 and 4. Now, that actually comes to us from exactly what we were doing last class when we were asked to factor a trinomial. So let's go ahead and do that to kind of relate the two. We're going to take the last number 8, and we're going to write down all the ways you can multiply to 8. No 3, 2 times 4, 4 times 2. You're repeating yourself, so it ends up with just 2 and 4. Next up, we want to try to come up with the two binomials that will make this add back to the b term, add to -2. So let's go x and x, and certainly not 1 and 8, but 4 and 2 are going to make this work. But what about your signs? Anybody have any suggestions? Yeah, with a perfect. A -4 with a +2. So we've got the two numbers that are going to multiply to -8 and then add back to -2. Now the whole point of this is to set the y value equal to 0. That's why we're calling them 0 values. So we're going to have x minus 4 and x plus 2 both equal to 0. And here's where I break them up and I write two little mini equations. Again, I'm trying to relate what we did last class to what we're talking about today. So I go this far, and I've just got a couple of tiny little equations, which we know what's going to happen. We're going to add 4, and 4 is going to be equal to x. I don't even need to show that work. Over here, I know I'm going to subtract 2 on both sides, and negative 2 is in fact equal to x. But look at this. The important part is we have negative 2 and 4. Oh boy, this is negative 2 and this is 4. So what you see in the graph is exactly what we had been doing the whole time with finding our 0 values. But let me get a different color. Domains, x values. This is going to continue on forever and ever this way and forever and ever this way. So the easiest way to write this is simply negative infinity, positive infinity inside of parentheses. Okay? It's going to the left, it's going to the right forever and ever. Next up, we got the ranges. So the ranges are the y values. Now, the y values have an endpoint, all right? So right here is as low as it goes, and everything is above it. Hopefully those colors are helping you and not making it more confusing. But again, this is negative 9. So the y values are above or greater than. They also include negative 9, so equal to negative 9. Too bad. So we've got the table filled out. We've got the points plotted. Now it's time to answer a couple questions. First one up, axis of symmetry. When you draw a line directly down the middle and cuts it into two equal sides. This is a vertical line, so it's x equals, and steal the x value. In this case, it is a 2, so x equals 2 for the axis of symmetry. And then the turning points. Well, we kind of started with that in the table, but, oops, new color. We started with that in the table. We can see it right here because it changes direction, and that was at 2, negative 1. Now those 0 values that we've been talking about for 2 days now, the 0 values are where it crosses the x-axis because it has no height. It has 0 for the y value, and that would be here and here. So that is when x equals 1 and 3. Now let's prove that those are the 0 values by doing a little factoring and setting it equal to 0. So we take a look at 3 because this value is a 1, and we don't have to worry about doing the hard way. We just know that the factors are 1 and 3. Well, that seems to be pretty easy, because if this is x squared, break it up into x and x, put a 1 here and a 3 here. I'll ask the audience for signs. It's got to add to a negative, but multiply to a positive. Yeah, good. So negative and negative. Now this is all about when y is 0. So we're going to change this to 0, and we're going to solve these little mini equations. 0 equals x minus 1, 0 equals x minus 3. And these are so tiny, you don't even have to show work. You know that you're going to add 1 to both sides, so x is going to be 1. You know you're going to add 3 to both sides, so x is going to be 3. And look at that. Same numbers that we found just by looking at the graph. So a pretty cool technique for you to use if you were ever to asked to do what we did last class. We finish up with the domain. Let me change my color again. Remember, the domain goes to the right and to the left forever and ever. Another way to write this would be to do a compound inequality. So I'll review that with you. Negative infinity less than or equal to x less than or equal to positive infinity. It's no different than what we did last time. It's just using inequality symbols instead of the parentheses. For the range, I'll keep it the same. I'm not going to change that up on you. And just going to make sure that we notice that this is the bottom of the parabola. Everything is above it. So the range is y, and the lowest number is negative 1. So that would put everything above, which is greater than or equal to 1. Ta-da! I did it in 15 minutes.